I'm doing a quick video on extreme value theorem. So, what does the extreme value theorem say? Well, it says, the theorem states that if f is continuous, so that without interruption, so there's no holes, there's no places where it's undefined. Normally you find this in polynomials. Where we don't normally find continuity is in your rational functions, your rational equations, as well as root functions or situations like that. So we are normally in a polynomial situation, and on a closed interval, a to b, then, so if it's continuous and we're on a closed interval, then f has both a minimum and a maximum. So extrema can occur at critical numbers. What are those critical numbers? They are when the first derivative is equal to 0 or when the first derivative is undefined. Now this is a closed interval. This is not an open interval, so we're not suggesting the whole graph has this. We're looking at very succinct points on our graph. What this says is that you are guaranteed to have a maximum and a minimum. And if you think about that intuitively, it makes sense, right? I mean, the only way for you to not have any maximum or minimum would be if the line were directly straight. So even if there's a slight slope in the line, then you're going to have a max and a minimum, okay? So whether the curve goes up and down or whatever it does, you will see on that interval a maximum and a minimum. It guarantees it as long as it's continuous. If it strays off and does something else for a while, in Never Never Land, well, then that's a different story. All right, so here's what the picture looks like. So we have some function, the x and y graph, and I've got this crazy function that keeps going down and down and down, and then all of a sudden it goes back up to a positive infinity. And what we do is we close it off. So in these green brackets you see here, this is the interval that I'm working from. And if we do, we can see that we have a relative maximum and we have a relative minimum. Again, if you want to look at absolute max and absolute mins, then that's a different time. But if we were to take this and shift it over, anywhere we went, we would find a relative min and a relative max, or a minimum or a maximum. Okay? So that's basically what we're looking at on a closed interval, and we're guaranteed a maximum and minimum. And that is what the extreme value theorem says. Well, let's put it into practice and see what we do here. So we have the function f of x is equal to 3x to the fourth minus 4x cubed, and we want to look at it on the interval from -1 to 2. So what do? First, we take the first derivative. F prime of x is equal to 12x cubed minus 12x squared. We set that equal to 0, and if we do, we will factor out a 12x squared, and we will get times x minus 1, and therefore if we set each of those to 0, we'll get x is equal to 0 or x is equal to 1. Now those are our critical numbers. If we want the critical points, we have to plug those values back into the function and get those y values. So let's see what happens when we do that. Alright, here's our number line, and at the top I have the slope of the line. And then in the middle here, I've got the critical values listed as 1 and 0. And then I've got my outliers here that they gave me. They're not really outliers, it's bad word. But my max, the lowest endpoint, and my highest most endpoint on the interval. Okay, so what I do first is I'm going to plug in some values into my derivative because I want to see what the slope is doing. Do I have a maximum at this point or do I have a minimum at this point? So I notice that if I plug in -1, and I'm going to go to the factored version here because it's easier. -1, well, an x squared is going to be a positive number, and then a negative minus another negative will be a negative number. So a positive times a negative gives me a negative slope. Well, then I hit 0, and I know that at 0, it is flat or horizontal, right? So now I'm going to go beyond that because I know at 1 I'm also horizontal. So what's the deal? There's got to be a relative minimum in here somewhere. And I find that, at 1/2, So I plug in positive 1/2. Positive 1/2 is going to be positive number here. And if I plug in a positive 1/2 here, that will end up being a negative number. And a positive times a negative is a negative. Now again, I'm not too concerned what the numerical value is, the quantitative value of what this is. I just want to know the qualitative value. What is it doing? Is it a positive or a negative in the slope? And I find that it's negative. So this thing must be coming down, and then it kind of lays low for a minute, and then it goes down again. So although 0's here, I would consider that to be, is that going to be a relative min or max or what? So now I go plug in 1. Now, and it's flat, and then go to 2, and 2, if I plug in 2, that's a positive number, and that's a positive number result, so I'll get finally a positive slope. Okay, so we're thinking, well, wow, which of these two has the lowest point? Because this one goes down, and then this one goes down. Well, it would seem that if we're going to graph this thing, that it probably does something. I'm coming down, I get flat, and then I come down again, and then suddenly I go back up, where this 1 right there is at a 0, and then, or 0 is at a flat place, as well as 1, and it probably looks something like that. And so as a result, I want to find out what they are really. And so I'm going to plug in the values that I've been given on the interval into my original function and see what I get in terms of the y values. All right, so if we plug in -1, well, that's going to stay a positive number, and then that'll be a negative number. So that makes a negative and a positive. So we get f of -1 is, it should be positive 7. It's positive 7, excuse me. So this is a positive 7. That's positive 7. And then, so we're up here somewhere. And then I'm coming down to 0. If I plug in 0, f of 0 is 0. F of 1, well, now if I go f of 1, that's going to stay positive -4. So that gives me -1 as a y value. And then over here at 2, so that looks like the lowest point so far, especially given that 1 is also has a 0 derivative. And now I plug in 2. F of 2, well, I'll get 16 out of that. So on the closed interval, my relative minimum would be at -1, and my relative max, or my maximum, would be at 16. Now, we could also argue that because on this closed interval that we're looking at max and a min, one might argue that those would be the absolute max or the absolute min given this interval as well. So, but I'm not here to argue that. I'm just letting you know where the maximum and minimums are. So, anyway, hope you have a great night. That is relative extrema and the extreme value theorem. Hope you enjoyed. Thanks a lot. Talk to you soon.